I'd like to do two examples of converting recurring decimals to vulgar fractions. A vulgar fraction, remember, just simply means a fraction with a numerator and a denominator. If we look at the first example, it says convert 0.702 recurring to a vulgar fraction. It's really important that you notice where the recurring dots are, because that tells you what string or which digits are recurring. You always put the dot at the start of the string and at the end of the string. So that one there actually means 0.702, 702, 702, etc. onto infinity. Now, if we're trying to convert this, what we start off by doing is we start off by labelling it. We give it a name so that we can actually do some mathematical operations and find an equivalent for it. And so the way we do that is we say let n equals 0.702 recurring. Now it's the recurring part I want rid of. So I'm looking to always eliminate the recurring part of that fraction. And the way I do it is I say, well, there's 3 digits there in the string, and the string comes directly after the decimal point. So I'm going to multiply it by 1,000. 1,000n is 0. It's not 0 point anything. It's 702.702 recurring. Because remember, that recurring part continues to infinity, as we've commented up here. Now what I want to do is I have to get rid of the recurring part. So it's this bit that I need to get rid of. And if I actually look further up, I can see that I could be taking away n itself, because n is 0.702 recurring. So if I do that, that's going to give me 999n is equal to 702. And I simply have an equation to solve. So I will divide both sides by 999. And that will give me n equals 702 over 999. And then when I simplify that, it will give me 26 over 37. So I can say, therefore, 0.702 recurring is equal to 26 over 37. Now, if you look at the second one is slightly different. And one of the differences is that it's a show that question. Now, what that means is that they've given us the answer already. They've told us we are aiming to show that this decimal, this recurring decimal, equals that vulgar fraction. The slight difference that you also need to be aware of is you need to be aware of the fact that the recurring dots are only over the 3 and the 0. So what that actually means is that this number is actually 0.1303030 with the 30 recurring. It's not the 1. You must be very, very careful to look where those recurring dots are to show you where the start and end of that string actually is. Other than that, we follow a very, very similar method. So we say let n be 0.130 with the 3 and the 0 recurring. I want to get rid of the recurring part. So I'm going to say there are still 3 digits after the decimal point. So I'm still going to go for 1000n. And be careful, because if I had 2 digits in the string, for example 1, I would have only multiplied by 100. If I'd only had 1 digit in the string, I'd have only multiplied by 10. But here, I've got 2 digits in the string that are recurring, but I've got another decimal place involved. So that's why it's 1000. That gives me 130.30 with the 30 recurring. Now I want to take away that 30 recurring. But I can't take away 0.30 recurring because there was a 1 there. I can, however, take away 1.30 recurring. Now, what that really is that's not n. That's 10 times as big as n was. So I'm going to take away 10n. And that will give me then 990n is equal to 129. Dividing both sides by 990, I get n is equal to 129 over 990, which when I simplify it, gives me 43 over 330, as required by the question. So your aim, each time you're doing a question like this, your aim is to eliminate the recurring part. Eliminate the recurring part. Okay. The method is very similar. As I say, what you originally multiply it by will change. So if we'd had 0.72 recurring without the 0 in the middle, we'd have had 100n up here. If we'd had 0.7 recurring, we'd have had 10n equals 7.7 recurring. So it's important that you stop and think about that.